Hello everyone. As far as last lecture is concerned, just try to recall, we have covered ISO SI reference model and a TCP/IP architecture and a protocol stack and the different protocols which are working at the different layers. So specifically in detail, we have seen application layer protocols in detail. That is what expected in your syllabus. Okay. Now today we will start with the physical layer of your ISO SI reference model. In last lecture itself, I told you that as far as theoretical discussion of computer network is concerned, you have to refer ISO SI reference model in detail, whereas actual or practical implementation of networking is concerned, then you have to go for or you have to refer TCP/IP architecture dominantly. Okay, so let us start with this physical layer. So physical layer of ISO is a reference model. Okay, it normally deals with the transmission media, the voltages, the raw data bits. Actually, it is handling. Okay, so the transmission media at a physical layer. Okay, it can be classified as a guided media or unguided media. So guided media is concerned, then you have different types of cables like twisted pair cable, coaxial cable, fiber optic cable. Whereas unguided media is concerned, the signal or the information is being transmitted in the form of radio wave or microwave or infrared wave. So a different equipments like printer, scanner and other things can be directly controlled with the help of infrared controller. Micro-ondas radio is normally used for Wi-Fi communication, Bluetooth communication, and the different wireless communication or data communication technologies which are there in existence. So they normally use this unguided media. So one by one we will see what are the different wired techniques for data communication and wireless technique for data communication. Just looking at this slide, you will immediately understand that as far as guided media is concerned, it's a wired networking, and unguided media is concerned, it is a wireless networking. Next. Now, as far as wired networking is concerned, we will start with the coaxial cable. So if you see the construction of this coaxial cable, the innermost part is nothing but a copper core. Thereafter, you have a insulating material, then a wire mesh conductor, and finally you will find a protective plastic coating is there. So this is what the construction of this coaxial cable. So with the help of this copper cable, this copper core and a wire mesh conductor, you are going to transmit a data or information with the help of these two things. Okay, see, this wire mesh is made up of mesh. The structure is mesh to reduce the electromagnetic interference. Okay, so these two wires, inner wire, that is copper wire, and another is wire mesh. With the help of this, the information is being transmitted from one end to another end. So various advantages of coaxial cable are there. Number one, good immunity to electromagnetic interference or RF interference, or highly intensive to electromagnetic interference. Supports high bandwidths. Okay, then up to 1 megahertz you can go and have the bandwidth, and accordingly the bitrate supported by that coaxial cable is going to be calculated. Then heavier types of coaxial cables are sturdy and can withstand with harsh environments. So these are the basic advantages of coaxial cable. Coaxial cable disadvantages: limited in network speed. So it is observed that compared to UTP cable, STP cable or fiber cable, the network speed is limited for this coaxial cable. Coaxial cable compared to UTP and fiber cable, they are bulky. It is amongst the most expensive type of wire cable. So these are what the advantages and disadvantages of coaxial cable. Now we will see a UTP cable, which is the most widely used cable for data communication. Okay, so there are two types of UTP cable: unshielded twisted pair cable. UTP stands for unshielded twisted pair cable, and another is shielded twisted pair cable. Unshielded, there is no shield around the wires. So let us start with this. UTP cable first, then we'll move ahead and we will have the discussion on STP. So UTP, the construction looks like this. Upper, the uppermost element is a plastic element. Then inside you will find color code insulation and these copper wire conductors are there. So basically while manufacturing itself, the wires are twisted to avoid the crosstalk and electromagnetic interference, to reduce the crosstalk and electromagnetic interference or EMI interference. Okay, four pairs are there. So four pairs. What's the purpose of these four pairs? Normally, two pairs for transmission, two pairs for reception. So in fast Ethernet, normally you can have such type of configuration. And sometimes one pair used for transmission, one pair is used for reception, and one pair for audio communication, and one for video communication separately. So such type of application also you can have with the help of this UTP cable. So what's the function? Unshielded twisted pair cable is used for data as well as information communication. This UTP cable look like this, and the dead end is nothing but a RJ45 connector. So with the help of this RJ45 connector, this UTP 4 pair cable is always connected. Now shielded twisted pair cable, compared to the previous cable, this shielding is used. In UTP there were no shielding, but as far as shielded twisted pair is concerned, you will have a shielding. What's the purpose of this shielding? Because of this shielding, okay, the electromagnetic interference, the control on this EMI is more compared to UTP cable. So such type of shielded twisted pair cable, okay, they are being used in the environment where the electromagnetic interference or RF interference sources are more, like industrial area where the motors, brushes, transformer, electric switching, high current switching, welding, okay, arc lights, such type of heavy currents and heavy electromagnetic sources which are unwanted and acting as a noise is available. That's why this STP type of cable, they are normally used in such an environment or industrial environment. STP cables are costlier than UTP cables. In our campus, that is in PICT campus, everywhere we are going for UTP cable because we don't have such industrial environment. And if it is needed, okay, we may use it. But right now, as far as most of the network is concerned, or maximum, it is a structured cable. The entire networking is a structured cabling, equipped with a structured cabling, and we are using um, unshielded twisted pair cable for this data communication. Next, these are the few advantages and disadvantages of a twisted pair wiring. One, reasonable cost, high speed, easy to add additional network devices, support large number of network devices. Thus, UTP represents the lowest cost cabling. The cost of STP is higher and is comparable to the cost of coaxial cable. So these are the basic advantages of twisted pair wiring. Then we will see the disadvantage. The main disadvantage of this twisted pair wiring is high attenuation or signal loss, limits individual runs after 100 meters. So after 100 meters, you will have to add the repeater or layer to switch. So this is what the limitation of this twisted pair wiring. And it is also susceptible to EMI and RFI interference. So if, as I told you, if industrial environment is there and if the noise sources of EMI and RFI is there, then definitely there is a solution over it. And for those specific area, you can directly go for shielded twisted pair cable. Now, these are the different categories of UTP cable normally used for data communication. Category 1, category 2, category 3, up to category 7. Okay, so up to category 7 I have mentioned over here with the different bandwidths. So category 1, less than 1 megahertz, voice only, so telephone communication, PSTN network. So normally such type of cable is being used for voice communication only. Category 2, the bandwidth is up to 1 megahertz, so data can be transmitted up to 4 Mbps, that is local talk and telephone T1 lines, etc. So T1 is a dedicated lease line where you can have such type of communication or data rate communication. Or data rate with the um, up to 4 Mbps is limited. Then category 3, the bandwidth supported for that wire is 16 megahertz and the data rate up to 10 Mbps is possible. So normally it is used for LAN application, token ring, 10-based applications and so on. Category 4, the bandwidth is 20 megahertz and the data rate is up to 20 megabits per second. So 10 VST, token ring, LAN applications, such type of applications are there. Category 5, the bandwidth is up to 100 megahertz and data rate is up to 100 Mbps. So you can directly say that for fast Ethernet implementation, LAN application, such type of category 5 cable is used. So in our PICT campus, we are using category 5 cable. So that's why the bandwidth is 100 megahertz, and in every laboratory and in every room, you will find a fast Ethernet implementation. Category 5 is one more category where the bandwidth is increased. The capacity of that wire is increased up to 350 megahertz and hence 125 Mbps data networks in special type of applications normally they use. Category 6 wire, it supports up to 550 megahertz bandwidth and it proposed standard for cable having a data rate of 200 Mbps LAN application. And category 7 is up to 600 megahertz bandwidth. So it is proposed for the standard of cable having a data rate of 600 Mbps using fully shielded cable. So STP type of application, local area network application, if you really want to know, the category 7 cable is nothing but STP cable and the bandwidth supported is 6 megahertz and 6 times than a fast Ethernet, that is 100 into 6, 600 Mbps bitrate is supported by such type of category 7 STP cable. Now we will move towards a fiber optic cable. So fiber optic cable is used for backbone. As far as PICT campus is concerned, we are using fiber optic backbone network. The meaning is, let us say in our campus, different departments are there. Let us say a computer department, E&TC department, IT department, girls hostel, boys hostel, and administration office. So what is happening? Our server room is situated in a main building, and from main building, let us say E&TC department, okay, E&TC department is more than 100 meters far away. Okay, so as I told you, as far as our local area network technology in our campus is concerned, okay, Ethernet or full duplex switch Ethernet, which is working on the principle of IEEE 802.3 standards, we have implemented in our campus. So what's a limitation of this Ethernet? After 100 meters, you have to have a repeater or layer 2 switch repeater in between, or you have to add a layer 2 switch in between. Then you can extend the network up to 100 meters more. Thereafter, again, you will require one more layer 2 switch. So that is what the limitation of this Ethernet network. But let us say if from server room, our boys hostel, girls hostel, or let us say gym, or let us say canteen is far away and it is more than 100 meters. So instead of connecting layer 2 switch after 100 meters, you can have a backbone network of fiber, so which runs up to few kilometers, 1 to 10 kilometers without any repeater. This is what the concept implemented in our PICT campus. So what is happening from server room to every department, whether it is com department, IT department, E&TC department, boys hostel, girls hostel, those who are more than 100 meters, there the backbone network is made up of fiber cable. So what is the main advantage of fiber cable? That without repeater, okay, without repeater, the data can be communicated over a distance of 1 kilometer to 10 kilometers. So this is what implemented, and for which fiber optic communication you have to understand in detail. So whatever expected from your syllabus point of view of fiber optic communication related topics, I'm going to cover in this. Right now I will cover it. Okay, we will see it. So following characteristic distinguish optical fiber from a twisted pair or coaxial cable: a greater capacity, smaller size, lighter weight, flexibility. Then you have a lower attenuation, low transmission loss, electromagnetic isolation, electric isolation, greater repeater spacing, more accuracy. These are the basic advantages. And the main advantage is this electromagnetic isolation. Since the information or the data is converted into optical range 380 to 780 nanometer, other interference, electromagnetic interference, RF or these noise, okay, they are not going to interfere to this visible range, and hence electromagnetic isolation or electric isolation, this is the main advantage of fiber optic cable over uh, coaxial cable or twisted pair cable. Following categories of application have become important for optical fiber. For example, local area network, then subscriber loops, long haul trunks, metropolitan trunks, and so on. Okay, so long haul trunks, metropolitan trunks, they are being used by the service provider as well as telephone exchanges for the further communication. So these are the various categories of applications. They have become important for the optical fiber. So one by one we will see. So what is the basic concept? What is the basic concept of this fiber optic communication? See this. The basic point of or the basic point-to-point fiber optic communication system consists of three basic units, which are those optical transmitter unit, fiber optic cable unit, and optical receiver unit. So if you see this, whatever data which is available, it is available with transmitter and you have to send it to receiver. Let us say this is the receiver. So in between this transmitter and receiver, you have fiber optic communications. How to do it? Transmitter, the immediate sensor or immediate transducer, not sensor, immediate transducer is in a such a way that which will cover the electrical voltage into light voltage, electrical information into light information. So this light information is going to travel through this fiber optic wire or fiber optic cable, and at another end this optical information is converted into electrical. So this is what called as fiber optic communication. So in fiber optic communication, a transmitter, fiber optic cable unit, and finally you will find optical receiver unit. So with the help of this, you can have a fiber optic communication. So what is the basic principle of operation? Fiber waveguide confines EM energy in the form of light to within its surface and guides the light in a direction parallel to its axis. So somehow this electrical information is converted into light information and it is being traveled in this fiber optic cable, and this light information, okay, again is converted into electrical signal with the help of a device like a photodiode or pin diode or phototransistor. So the transducer which is used at a transmitter end is a LED or laser which converts electrical information into light, and at another end light is converted into electrical information with the help of transducers or with the help of devices like phototransistor, photodiode, or pin diode. Now we will see the construction of fiber optic cable. The inner part is core, then you have a cladding, then silica coating, then strengthening fibers, and finally cable jackets. This is what the construction of fiber optic cable. A cross section you can directly see illustrating the different layers of this fiber optic cable. Now, as far as fiber optic classification is concerned, okay, there are two types. It can be classified as a based on material, and second is it is based on construction and principle of operation. So based on material, plastic core and cladding, glass core and plastic cladding, glass core and glass cladding. Okay, so these are the three types. So as far as fiber optic communication principles are concerned, okay, you can classify these fiber optic cables based on the construction and principle of operation, like single mode step index fiber, then you have multi-mode step index fiber, and finally graded index fiber. So single mode means single ray, then you have step index means core to clad. This refractive index is changing in steps, that's why it is known as step index single mode fiber. Multi-mode, instead of single mode or single ray, you will have multiple rays, so you can call it as multi-mode, but multi-mode, but step index, the core to clad index is changing in a step. And third is graded index fiber. Okay, graded index fiber means core to clad, this refractive index is being changed gradually, but not in steps. Here, N1, N2, only two steps are there. But there, from center to the end, the refractive index of that is changing gradually. That's why it is known as graded index fiber. So let us start with the single mode step index. So this is the single mode core clad refractive index is changed in step, and this is what the dimension. Core dimension is 8 to 12 micrometer core, and the cladding is 125 micrometer cladding. So this is what the step, a single mode step index fiber. Then we will see multi-mode step index fiber. So what is happening in multi-mode step index fiber? Instead of single ray, you will have multiple rays. That's why called as multi-mode step index fiber. But the core to clad refractive index is changing in step. That's why step index, but multi-mode. So what is the advantage? It supports hundreds of modes of propagation. Number two, easy power launching. Number three, LED can be used. In step index, here, what is the main thing? It supports only one mode of propagation. It is difficult for power launching because laser is must, because if you have 8 to 12 micrometer core in which you have to send optical information, you will require a device like a laser. So laser is must, and coupling becomes difficult if you go for single mode step index fiber. Whereas if you go for this multi-mode step index fiber, then LED can be used, then coupling becomes easy. But the main problem with this multimode step index fiber is pulse spreads in time causes intermodal dispersion. Okay, the discussion of this is important because the pulse is going to be spreaded in time. So this is the main drawback of this multimode step index fiber. And the construction is a core is of 50 to 20 micrometer, 50 to 20 micrometer core. That's why LED can be used for converting the electrical information into a light information. So the coupling becomes easy, and the cladding dimension is shown over here. So third type of fiber is nothing but graded index fiber. So as I told you, core to clad, this refractive index is not changing steps. It is changing gradually. That's why it is known as graded index fiber. So what is important thing is intermodal dispersion, which was a problem in this multimode step index fiber, is reduced with the help of this graded index fiber. This is the major advantage of graded index fiber. And graded index fiber have larger bandwidth or data rate transmission capabilities than step index fiber. So such type of fibers now we have seen. First, what we saw, a monomode, single mode, monomode or single mode step index fiber. Then second, we have seen multi-mode step index fiber, and third is graded index fiber. So these are the different fibers based on the principle of operation is used in fiber optic communication. Now this is about the guided media. So in guided media, what we have covered, just recall coaxial cable, its advantages, disadvantages, construction. Then UTP cable, its construction, advantages, disadvantage. Then STP cable, construction, advantages, disadvantages. And fiber optic cable, and compared to other cables, fiber optic cable has more advantages, more robust, the bitrate, the bandwidth supported, and the cost is also very less. So these are what the different guided medias, that is wireless networking media, we have covered so far. Now we will start with unguided media. So in very first slide I told you that guided media is nothing but wired communication, whereas unguided media is nothing but wireless communication. Now let us start with this unguided media. These media can carry electromagnetic signals such as microwaves, infrared light waves, and radio waves. So let us go through the electromagnetic spectrum which is available. So if you see a radio spectrum, microwave, infrared, ultraviolet, X-ray, gamma, and so on. So as far as this infrared to ultraviolet is concerned, you have a visible light. So 380 to 780 nanometer spectrum is available. And if you see the different application wide spectrum, that is twisted pair coaxial, AM radio, maritime band, FM radio band, TV band, terrestrial microwave, satellite, fiber optics. In fiber optics, 10 raised to 14 to 10 raised to 15, such a window and such frequency spectrum is used. And normally these frequency bands are known as LF, low frequency, medium frequency, high frequency, very high frequency, UHF, SHF, EHF, and THF. So all these details are given in next slide. So VLF stands for very low frequency, then AF audio frequency, low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extra high frequency, and so on. And thereafter, that is after 300 gigahertz. So this 30 gigahertz to 300 gigahertz, normally it is called as EHF, that is extra high frequency. Now the satellite bands, okay, they are indicated over here, and these bands are nothing but they are being started at 1 gigahertz and reaches up to 300 gigahertz and more than that. So what are those bands? L band, S band, C band, X band, KU band, K band, Ka band, millimeter band, and sub-millimeter band. So initially this L band was being used for a satellite radio receiver. Then S band, C band, this is the commercial band. In 1996, Dish TV and DTH, for DTH communication, they used to have a commercial band, C band satellite receiver. Nowadays, DTH or direct to home, whether it is Tata Sky or Dish TV, you are getting with the help of this K and KU band. Okay, that's why in C band in 1996 it was top analog, the Dish TV transmission was stopped. So there used to have a very big size antennas. But here KU band, because of high frequency and very high frequency, this KU band in the range of 12 to 18 gigahertz. Okay, because of this very high frequency, the dish antenna size is reduced nowadays. Okay, this is what the spectrum. Now there are three types of propagation. So whenever you are talking about RF communication, microwave communication, or unguided wireless communication, basically three types of propagations are there. Number one, ground wave propagation. So what is it? This is transmitter, this is receiver. The electromagnetic waves are being transferred up to the receiver with the help of earth surface. Earth surface is acting as a medium. But what is the problem with this type of ground wave propagation? The main problem is after 3 megahertz, this electromagnetic wave is going to die off. So signal does not reach to the receiver, and hence ground wave propagation is not used after 3 megahertz. So what are the application of ground wave propagation? You might have heard about medium wave transmitter or AM transmitter. So such type of radio transmitters and radio receivers are using such type of ground wave propagation. Number two, sky wave propagation. So now we have seen that up to 3 megahertz you can use ground wave propagation. What after 3 megahertz? Okay, there is nothing but a sky wave propagation. So what is happening in sky wave propagation? Sky wave propagation, the different layers, ionospheric layers are there in the sky. D, E, F1, F2. So the transmitter and this is the receiver. So transmitter transmit this information in the form of electromagnetic wave, and it is going to reflected back and coming to the receiver. So it is acting as a intermediate point from where the wave is going to be bent and it is coming to the receiver. So we are making use of this layer, and somehow this transmitted signal over a large distance is communicated up to the receiver. What is the problem with this sky wave type of propagation? It works up to 30 megahertz. So what is happening after 30 megahertz? It is called as maximum usable frequency. Beyond 30 megahertz, the penetration power of this electromagnetic wave increases in a such a way that it goes straight beyond this ionospheric layer. So it doesn't come back. And since it is not coming back, it is useless after 30 megahertz. And almost in all the consumer electronics, whether it is data communication, whether it is TV communication, radar communication, satellite communication, we have to use the frequency above 30 megahertz. So up to 30 megahertz, skywave propagation works. Like ground wave propagation up to 3 megahertz. Thereafter, waves dies, the electromagnetic waves, they are going to die off. for skywave propagation up to 30 megahertz. That is called as my maximum usable frequency. You cannot use this skywave propagation up to 30 megahertz. So you have to go for another type of propagation, is nothing but space wave propagation. So point to point, such type of propagation is useful, and almost all the application, wireless application, wireless data communication, we are using space wave propagation. So point to point communication is there. Only one disadvantage is there, that direct ray and indirect ray which is coming to the receiver causes a phase shift between those signals, and fading problems can occur. But a number of solutions are there, fake receivers and another anti-fading circuitries are there, and different solutions are there to take care of this, because there is no other option to go for this space wave propagation. So we don't have this ground wave or sky wave propagation option with us, so we have to go for this space wave propagation. Now, different types of point to point or wireless networking which are using unguided medias. For example, let us start with infrared communication. One system can communicate with another system with the help of infrared wireless communication. So infrared, the supported bitrate is up to 4 Mbps. So this is IRDA modem. IRDA, that is infrared modem, infrared modem. So you can transfer data at the rate of 4 Mbps, not more than that, with the help of this infrared. Only the problem with this infrared is, in between, if you have obstacle, then you cannot have communication. So point to point communication, you don't require any obstacle in between. So infrared WPAN, wireless personal area networking, you can go up to 4 Mbps. Next, these are the application that with the help of infrared trans receiver, you can have digital camera, pager unit, laptop, printer, infrared devices like mobile, palm top. You can communicate with this controller, and you can have an infrared data communication. Next, Bluetooth. The bitrate support is up to 720 kbps. The standard defined is 802.15.1. So system 1 can communicate with system 2 with the help of this Bluetooth communication at the rate of 720 kbps. Then you can go for Zigbee type of communication where the speed is 250 kbps. So the speed compared to Bluetooth is less in this Zigbee, but the distance and the power requirement will be lesser. And accordingly for Zigbee, this 802.15.4, such type of standards, they are used for Zigbee communication. Now we'll go for another technology which is not there in your syllabus, but still we will go fast, and you just look at these technologies which are there in existence. Vibri technology, where the Vibri modules are there, and which is working in the ISM band 2.4 gigahertz range, and the speed is more than Bluetooth or Zigbee, and you can have a speed of 1 Mbps. Then you have Y-Media 802.15.3 WPAN networking. So you can achieve a speed up to the 110 Mbps. So Y-Media trans receiver modules are available, and accordingly you can communicate. Then wireless USB WPAN networking. So speed is achieved from 54 Mbps to 1 Gbps. So such type of dongles are available which works on the principles of wireless USB, that is WPAN networking. Then you have one more technology known as ultra wideband, which works on the standards 802.15.3a. So it is called as WPAN networking. So speed is 480 Mbps to 1 Gbps. With the help of this much speed, you can directly have a communication between two systems with this UWP WPAN networking. And finally, we can compare these unguided medias which are being used for data communication in this slide. So it clearly indicates that this is what the distance between trans receiver in meters to kilometers, and this is what the bitrate supported, from few kbps to few gbps. So very simple, this NFC, Zigbee, Bluetooth, okay, you can communicate up to the distance of 10 meter and maximum up to 100 meters. So Wi-Fi can go up to 100 meter, but Zigbee, Bluetooth up to 10 meter, not more than that. Zigbee, Bluetooth and all this thing, you can have the data rate up to this 1 Mbps. Okay, if you want more, then you have to go for Wi-Fi. And Wi-Fi, the range is up to 100 Mbps. This bitrate is up to 100 Mbps, as well as the range is increased up to 100 meters. But if you want more data rate, let us say you want into 1 Gbps, then finally you have to go for wireless USB, that is ultra wideband, this type of application. And but the again range limitation is up to 10 meter. Though the bitrate supported is up to 1 Gbps, the distance limitation is up to 10 meters only. But if you want more distance to be covered with more data rate, then you have to go for a cellular data communication, that is GSM, 3G, 4G, WiMAX, and so on. So if you want more distance coverage and more data rate, then you have to go for cellular data communication. This is what the completion of physical layer of this ISO-SI reference model. So in ISO-SI reference model, physical layer handles the voltages, currents, the raw data bits, and normally the guided and unguided medias are discussed at a physical layer. So guided media, what we have seen, guided media, coaxial cable, UTP cable, STP cable, fiber optic cable. And as far as this unguided media is concerned, these are the different technologies with different distance support between transceiver, and different data rate is supported by the system is different. Every system has its own advantages, disadvantages, and application in the field of this wireless networking. This is what uh, the complete required discussion in this session. As far as physical layer in your syllabus is concerned, we have covered this physical layer, guided media, unguided media, and related fundamentals for this lecture. So now today we will stop for this session, and in next section we will see the layer 2, that is data link layer. And as I told you, data link layer is divided into two parts: upper part logic link control, and lower part, that is MAC, media access control. So in logic link control is there in your syllabus, and as far as logic link control is concerned, framing, flow control, data error detection, and correction, these are the different points which we are going to cover as a part of LLC in next lecture. So today we will stop here as far as today's session is concerned. If you have any doubt, you please ask me. Yes. And if you don't have any doubts, then we will proceed forward further, and we will meet you in next session. Okay. So next session we'll start with the LLC. Thank you. Thank you very much for listening this session with the patience. Thank you very much.